इलेक्ट्रिक फोर्स काम करत असताना दुसरा एखादा चार्ज आपण तिथे आणला, तर तो चार्ज तिथे आणण्यामध्ये जे वर्क डन होतं, ते वर्क डन त्या सिस्टीममध्ये इलेक्ट्रिकल पोटॅन्शियल एनर्जी म्हणून स्टोअर केलं जातं. आपण काय म्हटलं होतं की like charges repel and unlike charges attract each other. A charge exerts a force on any other charge in its vicinity. Some work is always done to move a charge in the presence of another charge. Thus, potential energy arises from any collection of charges. So, if we consider a positive charge q fixed at some point in space, for bringing any other positive charge close to it, work is necessary. This work is equal to the charge in the potential energy of the system. So work done against electrostatic force is equal to increase in the potential energy of the system. Work done against the electrostatic force. So we are talking about electrostatic or electric potential energy and we say that electric potential energy is equal to work done against electrostatic force. Work done against इलेक्ट्रोस्टॅटिक फोर्स. आता हा इलेक्ट्रोस्टॅटिक फोर्स आठवतोय का तुला? आपण मागच्या वर्षी एक कुलम्स लॉ शिकलो. जे जसा ग्रॅव्हिटेशनल फोर्स आहे त्याचा फॉर्म्युला काय आहे? कॅपिटल जी m1 m2 अपॉन डी स्क्वेअर. ओके नाही? तसा इलेक्ट्रोस्टॅटिक फोर्स काय आहे? k q1 q2 अपॉन डी स्क्वेअर. ओके नाही? where q is equal to 1 upon 4 pi epsilon 0. हे आठवत आहे?
हो.
हा कुलमचा लॉ होता की दोन चार्जेस आहेत, ते जर एकमेकांच्या जवळ आलेले असतील किंवा एकमेकांपासून काही अंतरावरती असतील तर लाईक चार्जेस असतील तर ते एकमेकाला रिपेल करतात, आणि हा जर निगेटिव्ह चार्ज असेल तर ते एकमेकाला अट्रॅक्ट करतील. हा जो अट्रॅक्शनचा किंवा रिपल्शनचा फोर्स आहे, त्या फोर्सची मॅग्निट्यूड, हा सुद्धा इन्व्हर्स स्क्वेअर फोर्स आहे की that is inversely proportional to the distance between the two charges is equal to k q1 q2 upon d square. तर ह्या इलेक्ट्रोस्टॅटिक फोर्सच्या अगेन्स्ट आपण जे वर्क डन करू, तो चार्ज त्या ठिकाणी आणण्यासाठी, ते वर्क डन त्या सिस्टीममध्ये इलेक्ट्रिक पोटॅन्शियल एनर्जीच्या रूपामध्ये स्टोअर केलं जातं. सो वी डिफाइन du, that is electric potential or change in electric potential energy, that is equal to f bar dot dr bar, f bar dot dr bar, where du is increase in potential energy of the system, du is increase in electric potential energy of the system, pe किंवा ep काय म्हणूया. F is the force exerted on the charge due to another charge or due to electric field also, and dr is the distance. Through which the charge is displaced. Distance through which charge is displaced. So this is the concept of electric potential energy. We will find now the expression for electric potential energy. Let us consider the electrostatic field due to a charge plus q placed at the origin O, and let a small charge plus q0 be brought from point A to point B at respective distances r1 and r2 from O against the repulsive forces. So let us find the expression for, हे लिहिलं का?
हो.
du is equal to f bar dot dr.
Into dear.
Yes. Now expression for this electric potential energy. इलेक्ट्रिक पोटेन्शियल एनर्जी ईपी किंवा पीई काय म्हणू शकतो आपण. ईपी समजूया, इलेक्ट्रिक पोटेन्शियल एनर्जी. इथे इथे त्याने म्हणताना डेल्टा यूज म्हटलंय, तेच वापरूया आपण, डेल्टा यू. So what are we considering? We are considering a charge plus q placed at point O, origin. त्याच्यापासून R1 आणि R2 इतक्या डिस्टन्सला दोन पॉइंट आहेत. So this is your point B, which is at a distance R2 from origin, and then there is a point A, which is at a distance R1 from the origin. At distance A, we have placed a small charge plus q, and which we are displacing through a small distance dr. म्हणजे आपण तो एकूण टोटल ए पासून बी पर्यंत घेऊन जाणार आहोत, त्यातली एक स्टेप म्हणून आपण तो स्मॉल डिस्टन्स डी आर कन्सिडर करतोय. तर रिपल्सिव्ह फोर्स काम करेल ना याच्यावर, हो की नाही? म्हणजे क्यू झिरो, हा जो प्लस क्यू आहे तो प्लस क्यू झिरोला रिपेल करेल, ढकलून देईल. म्हणजे आपल्याला जर तो ए पासून बी कडे घेऊन जायचा असेल तर या रिपल्सिव्ह फोर्सच्या अगेन्स्ट आपल्याला वर्क डन करायला लागेल, तर तो आपल्याला ए पासून बी पर्यंत हलवता येईल. तर हा खूप स्मॉल चार्ज का आपण कन्सिडर करायचा? तर ह्याचं जे इलेक्ट्रिक फील्ड आहे ते निग्लिजिबली स्मॉल पाहिजे, नाहीतर काय होईल की दोन्ही एकमेकांशी इंटरॅक्ट करतील आणि मग आपल्याकडे दोन इलेक्ट्रिक फील्ड होतील, असं नकोय आपल्याला. त्यामुळे क्यू झिरो हा आपण इन्फायनाइट सिमली स्मॉल चार्ज कन्सिडर केला की ज्याचं इलेक्ट्रिक फील्ड हे निग्लिजिबली स्मॉल आहे आणि ते त्या क्यूच्या इलेक्ट्रिक फील्डला हॅम्पर करत नाही, त्याला अफेक्ट करत नाही, असं आपण कन्सिडर करूया. सो वर्क डन अगेन्स्ट द इलेक्ट्रोस्टॅटिक फोर्स Fe in displacing charge Q0 through a small displacement dr appears as an increase in the potential energy of the system. So work done in displacing charge Q0 through a small distance dr. काय लिहितोय आपण? वर्क डन in displacing charge Q0 through a small distance dr against electric field of plus q. How much is that work done? We consider that small work done as dw, and that small work done dw is equal to Fe into dr. Fe bar, Fe is the electric force, dot dr bar, and which we write as Fe into dr with a minus sign. Why this minus sign is coming? Because the displacement and the force are in opposite direction. फोर्स कुठे राईटवर्ड आहे, हो की नाही? रिपेल करतोय आणि आपण डिस्प्लेसमेंट कुठल्या दिशेने करतोय? लेफ्टवर्ड ना. सो निगेटिव्ह साइन इंडिकेट्स as F bar and dr bar are in opposite direction. F bar and dr bar are in opposite direction. For the displacement of the charge from initial position A to final position B, the change in potential energy is delta U, and which can be obtained in the following way. So work done in moving charge plus Q0 from A to B, W is equal to delta U, that is increase in the potential energy, is equal to integration कुठपासनं कुठपर्यंत R1 पासनं R2 पर्यंत dW, that is equal to minus Fe into dr from R1 to R2. The electrostatic force, Coulomb force, between the two charges separated by distance r is, now we write the expression for the electrostatic force, आणि ते कुलम्स लॉ प्रमाणे येणार ना, की इट इज इक्वल टू 1/4 पाय एप्सिलॉन 0 1/4 पाय एप्सिलॉन 0 q into q0, the two charges, divided by r square. Now if it is a vector, we write a unit vector r cap, correct, and this unit vector r cap is in the direction of r bar. म्हणजे समजा हा इथला कुठला तरी पॉइंट आपण पकडला की जो r इतक्या अंतरावरती आहे, तर r बार ची डायरेक्शन कुठली असेल, r बार ची डायरेक्शन ओरिजिन पासून त्या पॉइंट पर्यंत ना, ओके नाही, हो r बार, आणि डिस्प्लेसमेंट त्याच्या ऑपोजिट साइडला आहे, सो this will be minus, because this negative sign is due to r bar and Fe bar in opposite direction. Position vector r bar and electrostatic force Fe bar are in opposite direction. So if we put the value of Fe in this expression, we can write delta U, that is equal to W, that is equal to integration R1 to R2 1/4 pi minus 1/4 pi epsilon 0 q0 upon r square into r cap dot dr bar. Which is equal to, now 1/4 pi epsilon 0 is constant, so that can be taken out of integration sign. Then q0, they are also constant, they can also be taken out of integration sign. So inside integration we have r1 to r2 1 upon r square into dr. One upon r square into dr. ऍक्च्युली Fe ला पण मायनस साईन आहे आणि त्या फॉर्म्युलात पण मायनस साईन आहे. दोन मायनस साईन झाले का? हे इथे हा dw हा इथलं मायनस साईन आणि Fe चा मायनस साईन, हे दोन्ही मिळून मायनस मायनसचं प्लस होईल. अशा प्रकारे एक्सप्रेशन करा. What is integration r raised to minus 2 dr? R raised to minus 2 plus 1 upon
अपॉन
r,
2.
हा अपॉन मायनस 1 ना, परत
हाँ अपॉन
minus 2 plus 1. So that is equal to r raised to minus 1 upon minus 1, minus 1 upon r. Correct. Minus 1 upon r. So together this expression will become, that is equal to 1 up q upon q0, q into q0 upon 4 pi epsilon 0 in bracket 1 upon r2 minus 1 upon r1. This is the change in potential energy of the system. The change in potential energy depends only upon the end point. So here R1 is your starting point and R2 is your final point. So the change in potential energy only depends on the starting point and the final point, and it is independent of the actual path taken by the charge. आता हेच यात पण होतं आपल्या ग्रॅव्हिटेशनल पोटॅन्शियल एनर्जी. म्हणजे एखादी वस्तू आपण इथून जर इतक्या हाईटला जर नेली आपण, तर त्याची पोटॅन्शियल एनर्जी आपण mgh म्हणत होतो ना. मग ती वस्तू जरी सरळ नेली किंवा वेडीवाकडी कशीही नेली तरी पोटॅन्शियल एनर्जी चेंज होत नाही. सो द टोटल पोटॅन्शियल एनर्जी इज इंडिपेंडंट ऑफ द पाथ टेकन. हे जसं ग्रॅव्हिटेशनल फोर्स मध्ये होतं तसंच इलेक्ट्रिक फोर्स मध्ये सुद्धा आहे, की ते हा जो क्यू आणि हा Q0 हे आहेत, चार्जेस आहेत, ते तुम्ही कुठल्या पद्धतीने नेताय किंवा कुठल्या दिशेने नेताय, कुठल्या पाथने नेताय, याच्याशी काही संबंध नाही. करेक्ट. इट ओनली डिपेंड्स ऑन द इनिशियल and the final position of the object. So it is equal to 1 upon 4 pi epsilon 0 q0 in bracket 1 upon r2 minus 1 upon r1. The change in potential energy depends only upon the endpoints independent of the actual path taken. Change in potential energy is equal to the work done against the electrostatic force. So far we have defined or calculated the change in the potential energy of the system of charges. But it is convenient to choose infinity as the point of zero potential energy, as the electrostatic force is 0 at r equal to infinity. This potential energy U of the system of 2-point charges Q1 and Q2 separated by a distance r can be obtained from the above equation by using R1 equal to infinity and R2 equal to R. So that is called the absolute potential energy. ही जी आता काढली ती आपण काढली relative potential energy. So it is the potential energy when it is moved from a distance R1 to R2. Then we write the potential energy, absolute potential energy, is work done to move a charge Q2 from infinity to at distance r from Q1. And that potential energy we write U of r as 1 upon 4 pi epsilon 0, this is the constant, into Q into Q2 upon r, correct? That is the starting point is the infinity, and final point is at distance r from q. येस, इथपर्यंत समजलं.
हो.
असंच आपण ॲब्सोल्यूट पोटॅन्शियल एनर्जीचा पण फॉर्म्युला काढला होता, इफ यू रिमेंबर. 11वी मध्ये त्याचं डेरिवेशन पण लिहिलं होतं, आणि 10वी मध्ये आपण विदाउट डेरिवेशन तो फॉर्म्युला अज्युम केला होता. 10वी सायन्स. कुठे हरवलं पुस्तक? असो, पुस्तक नाही आहे समोर माझ्याकडे आता. आठवते का ॲब्सोल्यूट पोटॅन्शियल एनर्जी आपण शिकलो होतो 10वीला?
काय आता फॉर्म्युला?
काय तो फॉर्म्युला आपण इंटरनेटवर बघू. ॲब्सोल्यूट ग्रॅव्हिटेशनल पोटॅन्शियल एनर्जी फॉर्म्युला. MGH ने, MGH हा फॉर्म्युला रिलेटिव्ह पोटॅन्शियल एनर्जीचा आहे. ॲब्सोल्यूट पोटॅन्शियल एनर्जी हा मायनस GMM अपॉन R असा शिकलो होतो. सेम आपण सेम लॉजिक अप्लाय केलं होतं की एखादी वस्तू ही इन्फिनिटीपासनं R इतक्या डिस्टन्सपर्यंत आणण्यासाठी जे आपल्याला जे वर्क डन करायला लागतं, दॅट इज इक्वल टू द ग्रॅव्हिटेशनल पोटॅन्शियल एनर्जी मायनस GMM अपॉन R. तसंच आधी हा सिमिलर फॉर्म्युला इथे आपल्याला मिळाला की 1/4πε0 Q1 Q2 अपॉन R. आता तिथे मायनस होतं, याचं कारण या कुठल्याही दोन मासमध्ये कायम अट्रॅक्शन फोर्सच असतो, हो की नाही? म्हणजे आपल्याला निगेटिव्ह मास माहिती नाहीये की असे दोन मास माहीत नाहीत की जे एकमेकाला रिपेल करतात. पण फक्त इलेक्ट्रोस्टॅटिक फोर्समध्ये काय असतं की देर आर पॉझिटिव्ह ॲज वेल ॲज निगेटिव्ह चार्जेस, अँड वी नो दॅट the like charges, they will repel each other, and unlike charges will attract each other. Here we are considering these Q1 Q2 as two positive charges, and that's why UR is equal to 1/4πε0 Q1 Q2 upon R. If one of the charges is of opposite nature, then the formula will also become negative here if the forces are attractive forces. So this is electrostatic potential energy and its expression. Then units of potential energy. We know that unit of energy is joule, and we define 1 joule of electric energy as 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. So 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. म्हणजे आठवत असेल तर आपण W is equal to Q upon V अशा प्रकारे तो फॉर्म्युला शोधला होता की सॉरी V is equal to W upon Q, the definition of potential difference. So W is equal to V into Q. So it is the work done in moving a unit positive charge from one place to another. So its unit is joule. Then we have a small unit of energy called electron volt. And 1 electron volt is the change in kinetic energy of an electron while crossing 2 points maintained at a potential difference of 1 volt. So that unit is 1 electron volt. So units of potential energy, we write two units, and here we are talking about the electric potential energy. Units of electric potential energy 1 joule, and we write 1 joule as energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt, and another convenient unit is electron volt. So 1 electron volt is equal to change in kinetic energy of electron, while crossing potential difference of 1 volt. And we have 1 electron volt is equal to 1.6 into 10 raised to minus 19, that is the charge on electron, joule. So you can see that electron volt is a very small unit of energy. It is of the order of 10 raised to minus 19 joules. Similarly, we also have 1 milli electron volt. मिली म्हणजे पुन्हा 10 raised to minus 3 ने मल्टिप्लाय करायचं, हो की नाही? So 1.6 into
होय.
10 raised to minus 22 joules. And we also have a kilo and mega electron volt. Kilo electron volt is 1000, so 10 raised to plus 3 ने मल्टिप्लाय करायचं. हे मिली आहे. Then we have kilo electron volt, which is 1.6 into 10 raised to minus 16 joule, 1000 ने मल्टिप्लाय केलं. आणि वी ऑल्सो हॅव मेगा म्हणजे कॅपिटल एम काढला, मेगा इलेक्ट्रॉन वोल्ट, दॅट इज 1.6 इंटू 10 रेज टू मायनस 13 जूल. अशा प्रकारे ही वेगवेगळी युनिट्स आहेत. सो दिस इज अबाउट द concept of the electric potential energy. The concept of potential, so equation we just now derived gives us the potential energy of 2 point charges at a distance r from each other, and we write that energy ur is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r. The quantity Vr depends upon the charge q and the location of a point at a distance r from it. This is defined as the electrostatic potential of the charge q at a distance r from it. So in terms of potential, we can write the potential energy of two charge system as ur is equal to V1R into Q2 or V2R into Q1. So now we define one more physical quantity, and that is electrical potential. हे जे expression काढलं, that was electric potential energy, and now we are deriving the expression for electric potential. Electric potential. So we write UR is equal to, that is electric potential energy, 1 upon 4 pi epsilon 0 Q1 Q2 upon R, which can also be written as Q1 upon 4 pi epsilon 0 R into Q2 or Q2 upon 4 pi epsilon 0 R into Q1. So this physical quantity Q1 upon 4 pi epsilon 0 R is called VR, or in this case V1R, and this is called V2R. So this we call as V1R and this we call as V2R. So we can write UR is equal to V1R into Q1 or V2R, sorry, into Q2 and V2R into Q1, where V1R and V2R are the respective potentials of charges Q1 and Q2 at a distance r from each other. So electric potential energy is equal to electric potential into charge. So we define electric potential energy is electric potential into charge, or you can write electric potential as electric potential energy per unit charge. That is V is equal to U upon Q. So this is the electric potential energy, which we can also write as U of R. U of R is equal to V into Q. Alternatively, what we can write, V is equal to U of R divided by Q. The electrostatic potential difference between the 2 points in an electric field can be written as, then the next is potential difference. Potential difference. V is equal to V2 minus V1, that is equal to U2 minus U1 upon Q, that is equal to dW upon Q. That is the work done per unit charge to move a charge from point 2 to point 1. So then we write the relation between electric field and electric potential. Relation between electric field and electric potential. So if we consider electric field produced by charge plus Q kept at point O, let us calculate the work done to move a unit positive charge from point M to point N, which is at a small distance dx from M. Direction of the electric field is along OM bar. Thus the force acting against the unit positive charge is along OM bar. Work done is equal to minus F into dx where F is the force and dx is the displacement. The negative sign indicates that we are moving a charge against the force. As it is the work done on a unit positive charge, dW equal to dV is equal to the difference in potential between M and N, that is equal to. So what is the expression for the force and expression for the field? So consider the electric field produced by a charge plus Q kept at point O. So what we are writing the relation between electric field and electric force. Relation between electric field and electric potential. So we are considering a unit positive charge, sorry, we are considering a charge plus Q kept at point O. Consider charge plus Q kept at point O. So here is point O and where we are putting a plus Q charge, and then we are moving a unit positive charge from M to N. Unit positive charge is plus 1 coulomb charge. आलं लक्षात सिस्टीम काय आहे ते की एक पॉइंट ओ आहे, त्या
हाँ
पॉइंट ओ ला तो प्लस क्यू चार्ज आहे ठेवलेला आहे. त्याच्या विसिनिटीमध्ये त्याच्याजवळ एम आणि एन असे दोन पॉइंट आहेत की ज्याच्यातलं डिस्टन्स स्मॉल आहे अँड दॅट डिस्टन्स इज डी एक्स सपोज. सो वी आर मुव्हिंग अ युनिट पॉझिटिव्ह चार्ज म्हणजे प्लस 1 कुलम चार्ज हा एम पासून एन पर्यंत आपण घेऊन जातोय. तर हाऊ मच विल बी द वर्क डन इन मुव्हिंग द चार्ज? dw विल बी इक्वल टू एफ बार डॉट tx bar, that is equal to minus f dx. Negative sign indicates that the force and displacement are in opposite direction. So what is the electric field in this case? Electric field is F upon Q0, बरोबर की नाही, किंवा F upon Q0, but our Q0 is 1 coulomb.
yes
We are moving unit positive charge, so we can write minus f dx same as minus e dx because Q0 is equal to 1 coulomb. So the negative sign indicates that we are moving the charge against the force, as it is the work done on a unit positive charge, dw equal to dv. So by definition this work done is equal to the electric potential. By definition this work done is nothing but the electric potential. So we can write the electric potential dv is equal to minus e dx, or we can write E is equal to minus dv by dx. So this gives us another definition of electric field. What is the original definition of electric field that we have studied in 11th standard? The definition of electric field, and we had said that electric field is a region around a charged particle within which a force would be exerted on the charged particles. And we have written the formula of electric field as 1 upon 4 pi epsilon 0 q upon r square.
Oh,
F upon Q असं म्हटलं होतं ना तिथे आपण. An electric field is defined mathematically as a vector field that can be associated with each point in the space. The force per unit charge exerted on a positive test charge or the at rest at that point. So E is equal to F upon Q. अशा रीतीने आपण त्या इलेक्ट्रिक फील्डचे डेफिनेशन 11वी मध्ये शिकलो होतो. Force per unit charge. So same quantity electric field. One definition is F upon Q, that is force per charge. But now we have another definition, that is equal to minus dV by dx, that is nothing but potential difference किंवा potential per length. Thus the electric field at a point in an electric field is the negative of the potential gradient at that point. So this quantity minus dV upon dx, that is potential per unit length, we define it as potential gradient at that point. So electric field can also be defined as potential gradient. So 1 unit of the electric field is Newton per Coulomb, F upon Q, and other is volt per meter. So Newton per Coulomb and volt per meter are one and the same units, and you can like analyze it. How do we define a volt? 1 volt is 1 joule per 1 coulomb, isn't it? 1 joule per 1 coulomb, and 1 joule is what? 1 joule is 1 newton meter upon 1 coulomb. And what is 1 newton? 1 newton is 1 kilogram meter per second square into meter per coulomb. And the another definition is so volt per meter is what? Upon 1 meter. So we divide at meter, and that is equal to 1 kilogram meter per second square per coulomb, and kilogram meter per second square is Newton, so it is Newton per coulomb. So volt per meter and Newton per coulomb are one and the same, and we saw this here also. म्हणजे व्होल्टचं जे युनिट डिफाईन केलं आहे आपण ते अशाच पद्धतीने डिफाईन केलं आहे की ते व्होल्ट पर मीटर आणि न्यूटन पर कुलम हे दोन्ही सारखेच असतील. देन दे आर आस्किंग the potential at a point A in the space is given by 4 into 10 raised to 5 volt. Find the work done in bringing a charge 3 microcoulomb from infinity to point A. Does the answer depend on the path along which the charge is brought? So potential at point A is 4 into 10 raised to 5 volt, and the charge is 3 microcoulomb, that is 3 into 10 raised to minus 6 coulomb. So work done in bringing the charge from infinity to point A is W is equal to Q into V. From where this has come, the definition of potential is amount of work done to move a unit charge. So it is W upon Q. So W is equal to V into Q. So voltage is 4 into 10 raised to 5, and Q0 is 3 into 10 raised to minus 6. So that gives us the work done is 1.2 joule. And work done is independent of the path. So it doesn't depend on which path is taken. It only depends on the initial and final point of the charge. If 120 joule of work is done in carrying a charge of 6 coulomb from place where the potential is 10 volt to another place where its potential is V, then find V. So potential difference is given, VB minus VA, which is equal to WAB upon Q0, work done in moving the unit charge from A to B upon the charge. So VB आपल्याला फाइंड करायचा आहे. So V minus the initial potential, which is VA. So VB minus VA is WAB upon Q0. So V minus 10 is 120 upon 6, and that gives us V minus 10 equal to 20 and V is equal to 30 volt. So have you understood all the formulae that we have seen today?
हो.
सुरुवातीपासून सुरुवात करूया. काय काय शिकलो होतो आपण, म्हणजे 11वी मध्ये काय शिकलो होतो आपण, 12वी मध्ये काय शिकलो आता. तर सुरुवात आपण अशापासून केली होती की कुलम्स लॉ. कुलम लॉने आपल्याला फोर्स दिला होता की F इज इक्वल टू 1 अपॉन 4 पाय एप्सिलॉन 0 Q1 Q2 अपॉन R स्क्वेअर D स्क्वेअर काही म्हणूया आपण. सो दिस वॉज द एंटिटी फोर्स. नंतर आपण इलेक्ट्रिक फील्ड शिकलो होतो गेल्या वर्षी. दॅट इज इक्वल टू फोर्स पर युनिट चार्ज. सो F अपॉन Q0. सो दॅट इज इक्वल टू 1 अपॉन 4 पाय एप्सिलॉन 0 Q अपॉन R स्क्वेअर. दिस इज इलेक्ट्रिक फील्ड. खाली हवं तर नाव पण लिहूया येतं. दिस इज इलेक्ट्रिक फोर्स. दिस इज इलेक्ट्रिक फील्ड. Then this year we learnt about the electrostatic potential energy, that is delta U, and we defined the electrostatic potential energy delta U to be equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R. इथे आपण डेल्टा यू ने आपण इथे यू आर असं म्हटलं होतं. Then we define this is electric potential energy. Electric potential energy. Then we define the electric potential V, and we define electric potential V as Q upon 4 pi epsilon 0 R. This is electric potential. Electric potential. And when finally we define that electric field can also be expressed as volt per meter. So E is equal to minus dV by dx, which was initially we said that it is F upon Q0. So this was two definitions of electric field. So इथपर्यंत आपण शिकलो. हे समजलंय सगळं इथपर्यंत?
हो.
Next is electric potential due to a point charge, dipole and system of charges. Electric potential due to a point charge. So electric potential due to a point charge. आपण मगाशी इलेक्ट्रिक पोटेन्शियल एनर्जीचं एक्सप्रेशन काढलं. इथे इलेक्ट्रिक पोटेन्शियलचं डेफिनेशन आपल्याला काढायचं आहे. So again a similar figure is shown where a charge plus Q is kept at point O. Then we need to determine its potential at point A, which is at a distance r from it. As seen above, the electric potential at point A is the amount of work per unit positive charge which is displaced from infinity to that point. And as the work done is independent of the path, we choose a convenient path which is a straight line extending OA to infinity. Let M be an intermediate point on this path where OM is equal to X. The electrostatic force on a unit positive charge F is equal to 1 upon 4 pi epsilon 0 into Q into 1, the other charge is 1 coulomb. So q upon x square, x is the distance between the two charges, as directed away from O along OM. For infinitesimal displacement dx from M to N, amount of work done can be given as, means amount of work done to move unit positive charge in a small distance dx is dw is equal to minus f dx. Here negative sign appears as the displacement is directly opposite to that of the force. Total work done is equal to integration from infinity to r minus f dx, that is integration minus इंटीग्रेशन इन्फिनिटी टू आर एफ से एक्सप्रेशन लिया, विच इज -1/4πε0 q upon x square dx. If we integrate it, we get minus q upon 4πε0 minus 1 upon x from r to infinity, which gives us value of that w equal to q upon 4πε0 r, which is the definition of electrostatic potential at point A due to phi. ओके, नेक्स्ट टाइम लिहूया हे.
हो चालेल.
चालेल, रविवारी शक्यतो टेस्ट सोडवायचा प्रयत्न करा.
ठीक आहे.
चालेल, आज थांबूया.